since the theme was Wipeout, we had to create traps for all the other people to, like, so they don't pass the whole thing. So, our team, my name is Kay, also known as K-Show. I'm 10 and I'm going to 6th grade. Our team name is the Fireballs. And RSDLC stands for Robot System Development Lifecycle. Yeah, that's just something we learned. The test play, or the play step, is when you check for problems. So for this one, we had problems. We needed a longer wire to get it from this, which is the operator, to that, so to go under the table. An example of this week is when we tested the bridge. If the robots can't hold it, the bridge can hold it. The rethink step is when you try to solve any problems that come up. And like a problem is that when the robot was on that, it wasn't strong enough, so we had to add a gear system, so like a torque system, so it would hold it, and the motor underneath would have enough power. I'll show you that later. And an example. The robot, it's a trap door, so if a car goes by here, this sensor here, it can sense it, and then it'll fall down into this trap, and most of the time it breaks. And this button is a safety, so that the gate lifts up and fall and they die. Yeah. And then after 15 seconds, it should come back up. And then if you hit this button, the gate just lifts up, but the bridge doesn't go down, so you can pass. See, it comes back up. It comes back up. And if you press this button, it's basically a safety. And it's not working.
So you,
there you go. And it says half a See, and the gate doesn't go. And then the robot can cross. Yeah. So are there any questions? Any questions?
One time, what would you do?
Reconstruct the bridge and make it more stable. Yeah. Anyone else have questions?
Giho.
What is the most hardest and easiest part of this project?
The hardest was seeing if the programming and seeing if the robots could hold it. Because there's stuff underneath these motors. I can't take them out, but with the robot wouldn't. The robot was too heavy and it would fall right through, even when you on the button. Creating a torque system with the smallest gear and the largest gear was hard. Yeah. And then the easiest part was just probably building the gate. Yeah.
What was the hardest part of the obstacle?
Yeah. Any questions? All right, we're good.
Next up is Team Dolphins.
Can I ask the audience to give another round of applause for the ladies?
Hi, I'm Natalie. I'm 11 years old, and this is Sophia. Hi, I'm Julia. I'm 12 years old, and I'm going into 7th grade.
Hi, I'm Simo. I'm 14, and I'm going into 9th grade.
RSDLC stands for Robot System Development Lifecycle.
The build step is when you put together pieces to create the robot you design. An example from this week is putting together our obstacle robots. The program step is when you figure out the robot's movements and download it all on an NXT, which controls the robot. An example from this week is when we programmed our robot to spin. The theme theme of this week was Wipeout, so we built 2 obstacles that would try and knock a robot out of its tracks while they're trying to finish the entire course.
Our second robot drops a lot of balls onto the course once the sensor senses a robot coming. It will confuse the robot's color sensor.
The Rotator Robot we designed is to spin around and knock the robot off the course. We're going to show you. This is our ramp and our spinner. This is our touch sensor right here. When you touch the button right here, the spinner robot is it stops and but the balls keep falling. That's it. Thank you for. Oh, does anyone have any questions?
What exactly does a touch sensor do?
It dismantles the spinner.
Natalie, can you repeat the question on the microphone so the parents can hear?
Did we design the picture for ourselves so did we measure it? Yes.
How do you put all the balls in there?
It's held together by a rubber band so the balls will fall. So,
What would you do if you had more time?
We would make it more advanced and try and make it more efficient and more hard to get through.
happy.
So if you had to change one thing about your design, what would it be?
We would probably make the spinner robot's arms thicker and longer so it would be harder to get by.
All right, so this is going to go to Julia. I want to hear her talk. So Julia, what is the main purpose of this robot?
It's to stop the robot in its tracks so it's harder to get around the obstacle to the finish line.
Let's me only one question. What was the hardest part in building it?
Programming the Bluetooth. Thank you for listening.
Awesome people.
Can I just add a comment to that team, the ladies team? The reason I asked you to give a round of applause again was because they're ladies and they're going to be engineers and scientists, which is a big thing in America, correct? No? Yes. Thank you for agreeing. And then a little bit of a comment about each one of those. I think the first day they were kind of not really happy with each other, trying to figure out, I am a high schooler and I'm 14 years old. And then the other one that's kind of smiley, bubbly, And then Julia will make me guessing all the time. They're like, what is she trying to think? Or what is she up to? Everything is good. One word answer, right? We all have teenage kids, so they do that. They did. I think they bonded and they did more, and I saw more involvement, more active engagement in the process. So I'm very proud of you guys. And I tell you, after a few months, somewhere in an informal conversation, you will have a geeky situation to call out this experience, and it'll be a great one. So again, you did a great job, and another round of applause for the ladies.
Also, parents, if you have any questions after, when they take questions, feel free to ask them.
Oh, some of the questions like what's the hardest part, what's the easiest part, I reserve them. You have to buy it from me for $5. So, and then it applies to you too. Okay? Ask the same question again and again. You have to buy it from me.